Thanks for coming back. Here's our bonus video for day 5, June 8th. Monty's creation. If you remember, a week ago I created a toilet paper arch. Let's see if the same math we just used for the St. Louis arch works just as accurately here. Okay, so Monty's toilet paper arch. This is our bonus problem. If you remember, we did this a week ago where we measured everything out. We grabbed our stick. Hopefully you have a creation. You can do the same thing with your creation. The very first thing I wanted to do is put this at the origin. 0, 0. Okay? That's going to be our end point. If you remember, we measured the vertex was 15, 12. And the other endpoint we measured to be 30, oopsie, 30, okay? And then we drew it. That's the model of my arch. Now we need those 3 important points, okay? We need the 0, 0. We need the vertex, 15, 12. And we need that other endpoint, 30, 0. Okay? We know that given any 3 points, we can actually come up with the equation that models that arch. Serious. All right. So, since we're here, let's write out all of our vocab. Okay? Tails plus. Here's our height. Here's our distance. Okay, and we were using inches. Inches. What do we got here? Vertex. The line of symmetry, x equals 15. We got a 0. We got a factor. We got a solution. We got an x-intercept. Write this x minus 0. Remember all that? That's why we're doing this. Okay, same thing over here. We got a 0. We got an x-intercept. We have a solution. And we have a factor. X minus 30. Okay? That's why we do all these problems. They model the real world math. Okay? Just to refresh our memory, we did this a week ago. I hope that you're measuring your arch that you created. Make one today. Just bend something, create an arch, measure it out. Serious. You could. All right? How about I see you in a moment to do the math? Okay, now let's do the math on Monty's toilet paper arch. This is the bonus problem. We're just going to do the math now to see if we can be just as accurate with a homemade arch as they are with something as beautiful as the St. Louis arch. Okay, we had 3 endpoints, remember? 0, 0, 15, 12, 30, 0. Let's just write them out, okay? So, the very first one, 0 equals a times 0 squared plus b times 0 plus c. 12 equals a 15 squared plus b times 15 plus c. 0 equals a times 30 squared plus b times 30 plus c. Now remember, this is just substitute, replace, solve in the generic standard form of a quadratic. Ax squared plus bx plus c. Now, the beauty of using the origin as our start point is the math goes away, right? That becomes 0, that becomes 0, which simplifies the math because c is 0. One of the variables is gone. Poof. Okay? So, as we do the math, that's a 0, that's a 0. All right? So now let's do the rest of this, okay? So we're going to expand this one out. 12 equals 15 times 15, 225. A. 15B. 0 equals 30 times 30. 900 A plus 30B. Again, 2 equations, 2 unknowns. You have the skills to do that. Yes, you could use photo math, but we're above that, right? Come on, let's do the math. The beauty of this is it's just double, just like last time. Just multiply the top equation times 2. Serious, okay? So bring that down. 12 equals 225A plus 15B. We're going to multiply everything times a -2. -2, -2. That times that, that times that, that times that. Okay? Giving us -24, -450. Yeah. -450A minus 30B. Bring down the other equation. 0 equals 900A plus 30B. Okay? 2 equations, 2 unknowns. It's the elimination method. Poof. That goes away. Leaving us with -24 equals positive 450A. Divide both sides by 450. And our A value this time isn't nearly as messy as the other one. Our A value here, -0.0535. Okay? All right. Okay, and we know A. How do we find B? We know A. How do we find B? Substitute, replace, solve. Just pick one of the equations and plug it in. Again, I'm kind of in favor of the 0. Anything equal to 0 should be fairly easy. So now let's go the other direction. Take this, I'm going to put it into that equation. Okay? All right. So now 0 equals 900 times -0.0535. Now remember that negative, smiley face, frowny face. This is an arch, so we like that negative A value. That's what makes the graph go frowny face, right? Open down. Plus 30B. 0 equals 900.0325. Oh, wow. Isn't it neat how these numbers just turn out perfect? -48 plus 30B. Add 48 to both sides. 48 equals 30B. Divide by 30. Divide by 30. And B is 1.6. All right? So now we have our A. Boom. We have our B. Boom. We have our C. Boom. Now comes the real test. Let's write out the equation and see if it works. So y equals A -0.0535 x squared plus 1.6x plus 0. All right? Let's test it. All right? Okay. Now to speed this up, yes, I had 2 different calculators. So y equals -0.053. Now, I didn't realize when I did this, when we divide this out, I misread my writing. 24 divided by 450. 24 divided by 450 was 0.05333333 repeating. I wrote that out wrong. So this is 33333 repeating to get our 1.6. Okay, so now I'm going to change this. 33333 repeating. Okay. Now, my calculator only lets me go out to 6 times, so I got 0.0533333. Okay? X squared plus 1.6x plus 0. Second table, 0, 0. The first data point came out 0, 0. So far, so good. Don't laugh at me. 0 times 0 plus 0, 0. Okay, that's fine. All right, now let's go to the next one. Second table set. We want to go out to 15. 15 comma 12. Win-win. Now the real test. Let's go out to 30. 8 zeros with a 3. So at 30, 1, 2, 3, 4, 5, 6, 7, 8. That's pretty accurate. I'm happy. Okay? So even real world math, building this little goofy toilet paper arch has yielded an equation that's to 9 decimal points accurate. So cool. I'm glad you joined me for this video, and I hope you created an arch. Measure the zeros, the vertex, do the math, be proud of yourself. Have a great Monday. I know we ran over. I'll see you in the virtual classroom.